How you doing? Today we're going to talk about SpacePak. We're going to go over some of the principles of how it works. This particular system is a high static unit, so we're designed for around 1.2 to 1.5 inches of static pressure. That being said, we use a 9-inch round plenum, is what you see here, main trunk, and then we use 2-inch supplies to feed into the space. Okay. The cool thing about our unit being a high pressure, high static unit, we're running half the CFM. So your conventional system would run around 350 to 400 CFM per ton. This particular unit's going to run somewhere around 220 to 250 per ton. So half the airflow, and what that does is it's going to help us pull out more humidity. Okay, so when we're cooling, we're half the airflow, but yet we're transferring the same BTUs, so we're pulling out about 30% more humidity than a conventional ducted system. Okay, so the way it operates again is our pressure here, okay, all our pressure is in here, we're up to about 1.2, 1.5. That pressure is going to change the velocity, so we're going to see somewhere around 1,500 feet per minute coming out of this outlet, and that converts to somewhere around 33 to 37 CFM per outlet, okay? And each one of these outlets, we need about 6 per ton, all right? A lot of people do it different. They might go 6, 7, 8 per ton, but our minimum outlets per ton is 6, okay? And if you do that math, 37 times 6, you're going to be somewhere around that 220 CFM per ton, okay? We're going to go over setting up the EC motor on the SpacePak air handler, variable speed. We have 5 set points on this. Some of the tools that are needed in order to set this up is a voltmeter that reads DC volts, a manometer that will read up to at least 1.5, 1.8 inches water column, and then a velocimeter so we can check airflow at each outlet to make sure we're balanced. All right, so moving into checking static pressure and setting up this blower. I find that if we can dial that blower into that static pressure that we're looking for, around that 1.2, 1.5, everything else should kind of fall into place. So what we do is we're going to measure out about 12 inches off that blower, and you're going to drill a hole into your duct. Okay, we're going to have our little 8th hole, and you're going to want to check the surface pressure. We're not going to take the tube and stuff it into the trunk because you'll get a false reading. This being our test lab, I have a cord already here, so it's a little bit easier for me. So I'm going to plug this in, okay? And as we turn up the blower, we're going to look at our static pressure. So now that the manometer is plugged in, I'm going to show you how to set up this blower. What we're doing is a single-stage cooling unit, so we're only going to adjust one flow. On our label inside our unit, it tells you which knob is each flow. So for instance, flow 01 is our cooling 1. So that is right here. So I'm going to adjust that with this thermostat screwdriver to try to get myself up to somewhere around 1.2 inches of static pressure. Okay? Bouncing around with 1.2, 1.3, which is totally fine. And that being done, everything else, again, should kind of fall into place as far as our airflow going out of our supply tubing. So I can show you that. So after making my adjustment here on the blower, getting myself to around that 1.2 inches of static pressure, I would advise whether it's yourself or your coworker to come down and check the velocity at each one of these supply tubes, okay? So with my meter, it's a Bluetooth meter and it reads onto my phone, but I'm somewhere around 1,450 to 1,500 feet per minute, which equals that CFM that we're looking for, around 33 to 37 CFM per outlet. When we're dealing with these outlets, we do got to make sure we're over 20 CFM, because if we're not aspirating. And the way this operates is off that aspiration and the mixing of air. Okay? So anywhere around that 33 to 37 is going to give you that adequate airflow that you're looking for. All right, we're going to go over the return side of the air handler, but I do want to touch on the fact that this air handler, our 2430 up to our 4860, is about 14¼ inches high. It's designed to be able to fit up through the joists. So if you're doing a retrofit, you should be able to cut a hole and fit this right up, and then our return grill will fill that void. Okay, because it is such like a shallow kind of unit, we have an oval return to try to get maximum airflow across this coil, and we also use an odd size return. So on the 2430,
we use a 15-inch round, and it is a sound attenuated return, okay? And some of the rules are we want to have at least 190-degree bend before we get into the back of the unit. And the reason for that is if you see a motor, you're going to hear a motor. So by adding that 90, it's going to deaden that noise. You hear all these things about high-velocity systems being loud. They're typically not if they're installed right. But you could find that you'll have return noises if you have too short of a return or not have a 90. So that's where we really want to focus on. So this round return, we kind of want to yank it a bit to make it an oval to be able to fit around this and put it on the back of the unit. I realize it's a lot easier for me to do this because I'm standing here than it will be for you in the attic, but it can be done and it works great.